Welcome to Feeder 18 demo. Feeder 18, or F-18 in short, is a low-voltage fully integrated electrical engineering software package, whose main objective is to determine, for a given project, service and feeders calculated loads, and corresponding conductor and raceway sizes, including branch circuits. It also calculates OCP ratings, voltage drop, step-down transformer sizes, busway ratings and grounding and bonding. In addition, it includes an estimated bill of materials and corresponding costs for every circuit and the total cost of a project. Calculations are based on the 2014 NEC edition. The program addresses residential, commercial and institutional buildings. Use of this program will eliminate guessing solutions, tedious and time-consuming calculations, waste and oversizing of materials and equipment. Clicking the Next button will display a new screen. There are 3 frames on this screen. The upper frame gives us the opportunity to select where the project data will be saved, on the hard disk or on a flash drive. The lower frame shows an information note telling us that F-18 supports multiple occupancy projects. Note that the Next button located on the lower right corner is disabled. It means that some data required to complete this screen is missing. The only data that is missing is the selection of the drive where the project data will be saved. Let's select the hard disk. Note that the Next button's color turns to green, meaning that we can proceed to the next screen. This screen has several frames plus the menu bar. The project frame has the options to manage a project. We can run a new project, or edit data of an existing project, or delete an existing project, or rename an existing project. To understand the structure of this program, in the information frame we will select the F-18 block diagram. Basically there are 3 frames: the input data modules, the recap input data modules and the output modules. The input data modules consists of 3 modules: the presentation module, we are now in this module, then the input common data module, where the serviced system, the service voltage, and miscellaneous data are defined. The third module is the input variables data, where the variable data of each circuit is defined. The recap modules enables us to have a documentation of the data that was input in the former modules. It also shows the result of the service and feeders load calculations. The output consists of 2 modules. The calculation module, where wire size, conduit size, voltage drop, OCP etc. are defined. Finally, the results module will show the results of the calculation module and a bill of materials, where conductors, conduits and corresponding estimated prices for each circuit will be listed. Let's examine now the information on the right side of the screen, related to job and file names. The idea of a project consists of 2 elements, a job name and a file name. A job name may contain several file names. These combinations help to better organize the projects. Now, with a basic understanding of the program, we are ready to start a new project from the next D examples of the NEC book. We are going to run example D4B, which is for a multifamily dwelling. Note: circuit lengths, conductor types and raceway types were assumed by F-18. The best way to enter correctly the corresponding data is to have ready a sketch of the one-line diagram of the project. Since a multifamily dwelling has many apartments, in principle, we would have to enter the branch circuit data for each unit, which translates in a lot of repetitions. However, in F-18, instead of this wasting time procedure, there is a simplified method, where all of the feeders that supply the same equal apartments are shown as a single feeder, a generic feeder, where we will be able to specify its number of repetitions. This will be reflected in our one-line diagram, where the number of repetitions are shown as NR. Following is a sketch of the one-line diagram. The one-line diagram on the left follows the description of example D4B. Starting from the service point we have the service conductors, which are identified as main and F-18. Then, from the service disconnect, there are 2 feeders identified as F_bank 1 and F_bank 2 supplying 2 identical meter banks. It is to be noted that in F-18, the end side of the feeder is a bus identified with the ID of the feeder plus the suffix bus, which is set automatically by F-18. Accordingly, the end side of feeder F_bank1 is identified as F_bank1 bus. Same criteria is valid for every feeder. Now, continuing downstream, each meter bank feeds 20 load centers corresponding to the dwelling units. Following is a summary of the branch circuit characteristics derived from each load center. Now, on the right side, we can see the equivalent simplified one-line diagram. Note that in this case, the drawing shows just one meter bank supplied by a generic feeder called F_bank with NR equals 2. NR stands for number of repetitions. Of course, in its internal calculations, F-18 will interpret that there are 2 meter banks with the corresponding 2 feeders. Following downstream, the simplified one-line diagram shows just one load center, but with NR equals 20, which corresponds to the 20 dwelling units derived from the generic meter bank. Note that from the viewpoint of the service, the total number of repetitions is 2 times 20 equals 40. We are now ready to enter data for the new project. In the job name box we enter an XD. Note that at this point, the next button is still disabled. This is because some data is missing in order to be allowed to proceed to the next screen. However, as soon as we start typing in the file name box, the next button color turns to green, signaling that all of the required data by F-18 in this screen has been fulfilled. We type D4B and click Next. This screen corresponds to the input common data module. We changed the default values as follows. For the system, single phase. For the system number of wires we accept the default value of 3N. For the system phase to neutral voltage we accept 120 volts. Other data is not obligatory, so the next button color is green. We click Next to proceed to the next screen. This screen corresponds to the input variables data module. It is in this module that each circuit's variables data is entered. Each circuit variables are defined in 3 consecutive screens that are called as pages PG1, PG2 and PG3. The contents of these pages are different, according to the occupancy type, the circuit type, if it is the service, or a feeder, or a branch circuit, etc. Data entered by the user is validated on the spot, and the program is practically shielded against input errors relative to the associated ranges presented by F-18. Data entered for each circuit is saved in memory while operating on pages 1, 2 and 3, until we click the record button on page 3, which will save, for the circuit under consideration, its data to the hard disk or to the flash drive, depending on our previous selection. The only exception is when we delete a circuit, in which case it will be deleted right away. Let's take a look at this page 1. It is for the service. Recall that the service conductor's ID is main, which is a reserve word in F-18, so its name appears in the corresponding box. We accept the default values presented by F-18 for equipment terminations, ambient temperature and sunlight exposure. No other data is required, so the next button is enabled. However, before clicking it, let's see other info on this PG1. The left pane will show the one-line diagram which is being drawn by F-18 while the circuit data is inputted. We click Next to proceed to page 2. The presentation of this page 2 is valid for the service conductors. Here we select the conductor's type in the raceway. We turn to the one-line diagram sketch where we see that the conductors are crew XHHW2 and the raceway is rigid metal conduit. After clicking on the corresponding options we proceed to the next page. On this page 3 we select the OCP type, and the length of the main conductors. For the OCP we accept the defaults presented by F-18. The circuit length is 20 feet according to the sketch. Note that the valid range is 10 to 500. Note that the record button is disabled. It will be enabled once we type a valid number in the length box. Begin by typing the digit 2. Note that the record button is still disabled. The moment we type the number 0, the record button color turns to green. We can go back to page 2 and page 1, just to see if no corrections or editing is required, and then return to this page 3. Recall that data entered up to now for current circuit resides in the memory of the computer. Once we click the record button, the circuit data will be saved to disk. Let's do it and then click the next circuit button. Note that we have returned to PG1. According to the sketch diagram, the next circuit is feeder F_bank, whose ID will be typed in the corresponding text box. Now, we have to select its associated upstream bus from the existing buses list. The only one available is the main bus, so we select it. Next, to the question, is this a feeder? The answer is yes. Note that in F-18, a circuit derived from the main bus must be a feeder. Also, it is the one that defines the type of occupancy of the downstream circuits. In our case, the occupancy selected is apartment houses with permanent cooking, that is a multifamily dwelling. Look at the left pane of this page, where the current one-line diagram is shown. Now we proceed to the next page. The screen presentation of this page 2 is valid for feeders. Here we define the conductor's type, the raceway type, and the equipment grounding wire. According to the sketch diagram, the conductors are copper, THHN, and the raceway is EMT. Regarding the equipment grounding conductor, if the raceway is metallic, the code doesn't require one. However, for this example, we will accept the default values presented on page 2. Now we can proceed to the next page. The screen presentation of this page 3 is valid for feeders. Here we define the OCPD type, the feeder's length, and its number of repetitions. For the OCPD we accept the default values. From the sketch diagram, the feeder's length is 50 feet, and the number of repetitions is 2. In the case of multifamily dwellings, there is another question regarding to whether this feeder feeds a dwelling unit. The answer is no, because it doesn't feed directly a dwelling unit. Also, in the case of a feeder derived from the main bus, there is a question relative to the load calculation method. According to the sketch diagram, the answer is the optional method, so we changed the default to optional. Once we click the record button, the circuit data will be saved to disk. Let's do it and then click the next circuit button. Again, we have returned to PG1. According to the sketch diagram, the next circuit is feeder F, whose ID will be typed in the corresponding text box. Now, we have to select its associated upstream bus from the existing buses list. It shows the main bus and the F_bank bus. According to the sketch diagram, we select the F_bank bus. Next, to the question if it is a feeder. The answer is yes. Note that the occupancy box shows apartment houses with permanent cooking, which was inherited from F_bank feeder, and it is not editable. Regarding the equipment termination provisions, we select 60 degrees Celsius and click Next to proceed to PG2. We accept the default values shown on page 2, which are in accordance with the sketch diagram. Clicking Next, we proceed to page 3. Length is 50 feet. Note that for feeder F, it does feed directly a dwelling unit, therefore we accept yes, which is the default value shown on this page. According to the sketch diagram, the number of repetitions is 20. Once we click the record button, the circuit data corresponding to feeder F will be saved to disk. Let's do it and then click the next circuit button. Again, we have returned to page 1. According to the sketch diagram, the next circuit is a lighting branch circuit derived from the typical apartment load center. Its ID is light. Its associated upstream bus is F-bus. Because it is a branch circuit, it is not a feeder. This is a 120-240 volts lighting circuit, therefore it is a two-phase, three-wire circuit. F-18 shows that the load is connected between ABN. For the equipment termination option, we accept the default 60 degrees Celsius. Let's click the next button to proceed to PG2. Here we accept the default values presented by F-18, which conform to the sketch diagram. That is, THHN conductors, and EMT raceway. The load type is lighting and general use receptacles. According to the sketch diagram, the parent feeder area associated to its general lighting circuits is 840 square feet. Let's type it in the corresponding box. Let's click the next button to proceed. Note that the design of this page 3, which corresponds to a branch circuit, is different from the ones presented formerly for a feeder. Recall that current circuit is a lighting circuit. Its computed load was calculated by F-18 and the lower limit shown for the range corresponds to the minimum load according to NEC. Let's click the default button, which corresponds to 2520 volt amperes. The circuit length is 30 feet. Let's click the record button to save current circuit data to the hard disk, followed by a click on the next circuit button. We are now ready to enter data for a new circuit, which will be completed in the cycle of filling out the required data on pages 1, 2 and 3. Current page is PG1. According to the sketch diagram, the new circuit corresponds to one of the two small appliance branch circuits derived from the typical apartment load center. Its ID is SMAP1. Its associated upstream bus is F-bus. Because it is a branch circuit, it is not a feeder. Its number of phases is 1 and number of wires is 2. Load will be connected between AN. After this action, look that F-18 has completed several fields regarding the parent field actual load, its phase current and the neutral current. There are lots of help icons that contain info related to their associated objects. Because all of the required fields and questions on this page have been completed, we can proceed to the next page, PG2. Here we accept the default values presented by F-18, which conform to the sketch diagram. That is, THHN conductors and EMT raceway. For the load type, the selection is small appliance. Because all of the fields and questions in this page have been completed, we can proceed to the next page. Current page is PG3. According to NEC 220.52a, the computed load for a small appliance branch circuit is 1500 volt amperes. This value was set by F-18. The circuit length is 30 feet. Because all of the fields and questions in this page have been completed, let's click the record button to save current circuit data to the hard disk, followed by a click on the next circuit button. Now is the turn of the second small appliance branch circuit. All of the data is equal as for the first circuit, except for the ID and the load connection, which in the case will be between BN. Therefore, without any other explication, we will enter the data of the 3 pages of this circuit. To continue the cycle of inputting circuits, again we have returned to PG1. According to the sketch diagram, now is the turn of the range branch circuit, whose upstream associated bus is F-bus. It is not a feeder and has 2 phases and 3 wires. The parent calculated volt-amperes load and its phase and neutral currents have already been calculated by F-18 and are shown on this page 1. Now we can proceed to the next page. Current page is PG2. In this case, the conductor type is an armored cable, so we click on the AC option. Because this is an armored cable, the conduit load type selection frame and the grounding wire frame have been disabled by F-18. The load type is a range, which is an appliance. Then, to select it, we click the specific appliances or loads option, and from the appliances list shown we select cooking range. Since the next page button's green light has been enabled, we proceed to the next page. Page 3 is shown. According to the sketch diagram, the range load is 8 kilowatts and the circuit length is 30 feet. After entering these values, we record the data associated with this range circuit and proceed to the next circuit by clicking the Next Circuit button. According to the sketch diagram, there are 4 space heaters whose data will be entered one by one. Before beginning, let's take a look at the current one-line diagram shown on the left pane of this PG1. To have a better view, we can expand it and analyze the drawing. Let's name this space heater as SPHTR1. Its parent is F-bus. Current circuit is not a feeder. It is a 2-phase, 2-wire branch circuit connected between AB phases. Let's proceed to the next page. Current page is PG2. Conductor type is CUTH8N. Conduit type is EMT. Space heater rules are mentioned in Article 424. Though not classified as an appliance, it has been included in the appliances and other loads list from where we will select it. Now we can proceed to the next page. Current page is PG3. From the sketch diagram, the load is 1.5 kilowatts, equivalent to 1500 VA. And the circuit length is 30 feet. Because all of the fields and questions in this page have been completed, we can record the data corresponding to the circuit under consideration, and proceed to the next page. From the sketch diagram, the remaining branch circuits consist of 3 space heaters and 1 water heater. The input data is similar to the former branch circuits and it will be done, one by one. However, in order to save time, the procedure will not be shown in the demo. Current page is PG1. At this point, the process for inputting data has been finished. Therefore, let's run the calculation. This process will lead F-18 to the recap modules and then to the output modules. But beginning, from the File tab options in the menu bar, let's select Run Calculations. Current screen displays a recap of the common data, such as job and file names, system data, and items checked is not available. Let's proceed to the next screen. We have now entered in the Variables Data Recap module. This is the first page of this module, displaying the names of each circuit and associated parent bus, phases and wires, voltage, conductor and conduit types, and circuit lengths. Let's proceed to the next page. This is the second page. It shows for each branch circuit recap of the computed loads, as well as the corresponding calculated phase currents. It is also displayed the calculated loads for the service and feeders of this project. These data will be the basis for the calculations of the wire sizes, conduit sizes, OCP, voltage drop, etc. when the program enters in the output module, which is the next action after clicking the Go to Results tab. We are now in the Output Modules block. It consists of the Calculation module and the Results module. The current Calculation module determines wire and conduit sizes, OCP, voltage drop, etc. After the processing has been finished, the program connects to the Results module. Let's click the green color command to proceed to the next screen. At this point, the calculation process has been finished. Clicking the Go to Results button, F-18 will connect to the Results module. Finally, we got to the Results module. On this page we can see a summary of the calculations of this project, in an ordered and concise form, displaying the data required by the user of the project. In effect, for each circuit, we can see its OCP rating and OCPD type, the number of conduits, the type and size associated with the circuit under consideration, the number of phase conductors, the size installed in each conduit, along with the corresponding neutral conductors, the equipment grounded conductors size and type, and the phase and neutral conductors type. Also, the grounding and bonding sizes associated with the service. Results are based on the NEC. Page number B1 is displayed. On the left column are shown the voltage drop results at the end of each circuit. Let's analyze the three columns on the right side. The first column shows the single circuit cost of each circuit. For example, the cost of the feeder identified as F is $650. Recall that F is the generic ID of the feeder that supplies a generic dwelling unit, as you can see in the one-line diagram. The second column is NR, which stands for number of repetitions. It shows 40, which is the number of dwelling units. The last column is the total circuit cost. For F feeder, it is $650 times 40 equals $26,000. For the purpose of F-18, the individual price of feeder F is composed by the wiring cost plus the conduit cost. By clicking on the 650 figure of feeder F, we can see that the individual costs of the conductors is $369 and, for the conduit is $281, totaling $650. The total project cost is $99,824. Please note that above prices are based on F-18's estimated database prices, which is editable and particular to each project. Let's now proceed to the next screen. Current page displays a list of materials. For the purpose of this project, this list is referred to the conductors and conduits. It also shows a cost summary whose total shall coincide with the one shown on the former page. As it does. This is a double check. We have reached the end of this demo, which is based on an example in the Annex D of the NEC book related to a multifamily dwelling calculation under the optional load calculation method. Under development are demos for other cases, such as one-family dwelling, different cases of multifamily dwellings, commercial and institutional buildings, light industrial facilities, and many of the occupancies listed in tables 220.3 and 220.12. A tutorial is also underway. We hope that this presentation has been useful to you and thank for your visit and patience. For further information you can visit www.feeder18.com or drop an email to info@feeder18.com.